Section 4.1, that's what we're working on today. And Section 4.1 is an intro section to a chapter where we're going to look at how derivatives are used. Chapter 2 and 3, or Units 2 and 3, we worked extensively on finding derivatives, the procedural mechanical methods of actually getting the derivative. So now Chapter 4 will be fun. We'll get to put to use all those skills and determine what it means in context of problems. So example number 1 from the 2001 AP exam, both the AB and the BC kids had this one. I noticed it's question number 2, which means it was without calculator. The temperature in degrees Celsius of the water in a pond is differentiable function W of time t. The table to the right shows the water temperature as recorded every 3 days over a 15-day period. Every 3 days. Yep, we can see every 3 days. It goes from 0 to 15. That makes sense. What else is going on here? Underneath here, I see the W of t column. There's our Y, our output values. And it was in degrees Celsius. So every 3 days they recorded the temperature. Use the data in the table to find the approximation, W prime of 12. Show the computations that lead to your answer. Well, if I had an equation, I would just take the derivative, plug 12 in like we have been learning how to do in chapter 2 and 3, but they didn't give us an equation. So the other key word I see mentioned is that we want to do an approximation. So I know I'm probably not going to actually take a derivative of a formula, but rather use some numbers to help approximate it. They do have 12 and 22 listed, but I can't do a slope or a rate using just one number. So I'm actually going to kind of ignore that particular number, and I'm going to focus in on the data on each side of 12. And I'm going to use that to get the slope. So let's practice it here. W prime of 12 is about W of 15 minus W of 9 over 15 minus 9, right? So I've got change in Y, or change in W in this case, over change of X. That's what we think of when we do slope, right? In our scenario here, we really have got the change in W over the change in time, because those are our two variables. So let's just get the numbers put in place. W of 15 was 21. W of 9 was 24. 15 minus 9, I might as well just let that get copied there. Negative 3 on top, positive 6 on bottom, gets me to a negative 1/2. Use the data in the table to approximate W prime of 12. I did that part. Show the computations. I did that part. Indicate the units measure. Oops, I haven't done that part. We need some units here. W prime of 12 is about negative 1/2. And now I really can use those numbers that I put in place and look at what their label was. So the label for the top, for the function W, was degrees Celsius, and T comes in a units of days. So it's Celsius per day. Let's not do days. The scoring guideline for this particular problem issued 2 points. One for the quotient difference, and for that you must show your setup. So it's essential that you have the setup, and then of course you have to have the answer right. So 1 point for the answer, 1 point for the setup, okay? If you just had the answer, you wouldn't get 0 points. They consider that a bald answer, and AP awards 0 points for that. This answer had to come with the units too. So even if I'd had the negative 1/2, I still would not have earned the point until I got the label on it. Now, the next thing that's commonly asked for is that you take that answer you got and explain its meaning. So it says, what if we were asked to interpret the meaning of the approximated derivative value we found in example 1? Interpreting the meaning of a derivative in context of a problem will certainly be a question that you will encounter in the AP exam. The acronym NUT can help you in properly answering those questions. So guidelines when you're interpreting the meaning of a derivative. When interpreting the meaning of a derivative, make sure you reference the noun. Like in this case, we were talking about the water in the pond, right? And then also include the number, the numerical calculation that we came out with. So like the -1/2, I want to make reference to that. We want to talk about the units in our explanation as well as at what time this occurred, okay? So that would be like our 12 that we were calculating for. So include the time at which it occurred. I brought in the answer and get a little Celsius in there. So there is the calculation we used, and part B of this question says interpret the meaning of the derivative part A in context of the problem. And this was worth 2 points. I don't have the right scoring guide here. It is still worth 2 points. I'm sorry, I think I'm on the wrong page. I guess I didn't. I bet it was worth 1 point. I did not bring in the scoring guide for part B. Anyhow, moving on. Interpret the meaning of the derivative. So, what does -1/2 degrees Celsius per day reflect upon? What noun would that be reflecting to? Well, I think it's reflecting to the temperature of the water in the pond, right? So I'm going to start out with that noun. The temperature of the water in the pond is changing. You know what? We could even say it's decreasing since it's negative. Let's say is decreasing at a rate, because what we calculated is a rate, at a rate of, and I definitely don't want to write -1/2 on this. So when my computer catches up here, of 1/2 degrees Celsius per day. So I've done the noun, I've worked the number into it, the 1/2, and I've got the units. I said the word decreasing, so that took care of the negative. That's why I didn't want to put a negative in front of my 1/2, because otherwise I would have been a double negative, and that would not be correct. The decreasing word shows that I understand what the negative means as well. So it's decreasing at a rate of 1/2 degrees Celsius per day, and then now I just need to fit in the time at T equals 12. Do I want to put day? 12 equals 12th day. You probably even could just write T equals 12 and get the full points for it. Okay. Example number 2. This is where we're going to use our calculator, so go ahead and turn your calculator on. It says on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T equals 90 plus 45 cosine T squared divided by 18, where T is measured in hours and T is between and including the endpoints 0 to 8. At the beginning of the workday, T equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, the plant processed gravel at a constant rate of 100 tons per hour. That is jam-packed with information. So I would probably end up rereading it to get more meaning out of it. And this problem probably had 4 parts to it. We're going to try and tackle the first part. Find G prime of 5. Using correct units, interpret your answer in context to the problem. Now, G, I want to go find the G function. I found it. What was the G function? Well, one thing I noticed when I was reading is it said the rate in tons per hour at which unprocessed gravel arrives at the plant is this G of T. You would swear that this G of T is not a derivative, but yet they told me it is a rate. They just did not identify it as G prime of T, which is fine. They have that prerogative to name it any function they want. I just have to be wise enough to look at what the units are and what the words are surrounding G of T to know that that really is a derivative equation. So they want me to find G prime of 5. I need to take the derivative of G of T, which is really going to get me like a second derivative, isn't it? In my head, I know that because I was already starting with the derivative. Using correct units, interpret your answer to the context of the problem. This one has 2 points awarded, one for the interpretation, one for the analysis of G prime of 5. Unlike the previous problem, we don't have a table to work with. So on this one, I actually have a formula. So in our calculators, we are going to find G prime of 5. And I don't know that we've done this before, so this could be new for you guys. In our calculator, if you hit alpha window, you get many quick shot options. I like this format, this menu option, because it has a lot of what we use. The third option, N derived, stands for numerical derivative. So we're going to press numeric derivative. So I did alpha. You may want to write those steps down. Alpha window option 3, and that gets us the numerical derivative. It will calculate a derivative for us at the value that we put in. So you can kind of see the setup already. I'm going to put it in with respect to x. Even though my function is t, the calculator doesn't know that. I can let this be x just as well, couldn't I? So I'm going to put x in mine, and now I've got to load the equation 90 plus 45 cosine. Since I'm using a trig function, look and see, make sure that you are sitting in radians. And you can tell that if you have the CE model, it has radians right up in the header. So if you're not in radians, flip yourself over. That's done through mode, isn't it? Go to mode and make sure you're in radians. To get back, I'm going to go second mode, which is getting the quit command. Okay, I got to get myself back over into cosine. One more step, right there. I need x squared divided by 18. Now, at the very end, do you see the straight up and down line? Remember how that means evaluate? That's exactly what it means here. Evaluate this derivative when x is equal to 5 is our number. So I'm putting in 5. I'm going to hit enter. And there is my answer. I'm going to swipe this off so we can talk about it. There it came. All right. So now what do I want to write down for the AP? Since I did the work in my calculator and it was a calculator active problem, I'm fine with showing the left-hand side as G prime of 5. Use a capital G because that's how this function is referenced. And it's going to be negative 24.587. Or I could give them an answer of negative 24.588. Either of those are accepted. You can truncate, just chop it at 3 decimals, or you can look to the next digit and decide if it should be rounded. Now, I also need correct units. So my correct units, let me get rid of that. All right, the correct units. So T was measured in hours and G was tons per hour. So I'm going to have tons per hour was the output, right? Tons per hour is what G of T represented. But we did a rate on it, right? We took a derivative. So I get it over time. So I'm getting tons per hour. You also could write that as tons per hour squared if you prefer that notation. So really this is a rate of a rate, and that's why we get the hour squared, hour per hour. Now, in context to the problem, what does it mean? Well, this was unprocessed gravel arriving at the plant, right? So, and it is negative. So that tells me that it's decreasing, a decreasing rate at that time. So let's go back to our nut idea. Let's talk about the noun and the numbers. So the noun would be, we're calculating on a rate. The rate at which gravel is arriving at the plant well, we said the negative means it's decreasing, is decreasing and then I want to fit this number in by 24. Oh, I'm sorry, the computer is just not. Let me go and take some of that ink off from before. Okay, is decreasing by 24.5 588 tons per hour squared, because I want to work in my 588 tons per hour squared. And then finish it off with the T, the T part of the nut at 5, at T equals 5. I guess that would be hours, at T equals 5 hours. It's frustrating when you have to fight the computer. Okay, next, example 3. From the 2007, AB number 3, this was with calculator. The wind chill is the temperature in degrees Fahrenheit if human feels based on the air temperature in degrees Fahrenheit and the wind velocity V in miles per hour. If the air temperature is 32 degrees, then the wind chill is given by W of V equals negative 55.6 minus 22.1 V, which is velocity of the wind, raised to the 0.16, and is valid for a velocity that sits between 5 and 60. Find W prime of 20. Using correct units, explain the meaning of W prime of 20. So the wind chill a human feels based on air temperature, wind velocity in miles per hour. So if I thought about a chart, V would be my input, wouldn't it? And V is coming in miles per hour. My output was the W, and it, what was W? Wind chill is the temperature. So that would be degrees Fahrenheit. There we go. So I'm just going to kind of keep those units in mind. You know, it's reading those problems, and sometimes you have to do some searching to finally figure out where they're laying out those units. Find W prime of 20. So W prime, notice they don't say estimate, approximate, or anything like that, which means I should be very precise on this. Using correct units, explain it. Okay, so W prime of 20. I could take a hand derivative of that because I know how to do that, but instead, we're going to allow the calculator to do it once again. So I'm going to clear what I had previously, and now I'm going to put in alpha window option 3. You also can go under the math menu and get the n derive. I want to get the derivative, which was option 3, and now let's load in our equation, 55.6 minus 22.1. V, I'll put x raised to the 0.16, and then I want this evaluated at 20. Right here's where I'm picking that up. Hit enter, and we have our answer. Let me see if I can pull this off the screen. All right, so we have our answer here. Now, that answer would be negative 0.285, or another acceptable answer was negative 0.286. What would the units be? Output over input, degrees Fahrenheit divided by miles per hour. Kind of a weird unit. Would have been hard, I think, to come up with without a little bit of this analysis over here. Now, in context to the problem, what does it mean? Let me get rid of this. Yeah, talk about frustrating. Okay, got it. Didn't get it, did I? There. All right. So far we've got 1 point. We need to come in with the explanation. Wind chill is the temperature a human feels, but we are doing the rate of the wind chill, right? So, and it looks like it's decreasing. So the noun is going to be wind chill. Let's start there. The wind chill is decreasing by a rate of, I've already got the word decreasing, so now I just need to put in 0.286 degrees Fahrenheit. Get the unit now. We did the noun, we did the number, and now we're on the unit. And then when did this calculation occur? At t equals 20, and I believe that was in hours at 20. No, it was miles per hour. And it was actually V, wasn't it? Velocity. At velocity equals 20 miles per hour, because our input was V, which was miles per hour. I always think writing them out it takes a little bit of thought process and is not super intuitive. It's kind of good to go with that nut idea: a noun, the number, the units, and the time, and then you've got all your bases covered. Okay, so the next thing I think we'll do that together when we're together during next class period. So go ahead and skip over that next page in your notes. And I have 4-1 worksheet for you to work on. I think there are 6 problems on it, and they should be quite similar to things that we just did. You will note some of them you'll want to use your calculator, and then others not so much. So there, if you see the calculator symbol, you know that's a calculator problem. Very good. Have a great day.